also, because we need to talk about, like, these instructions were really similar to the instructions I left yesterday for the sub. So you were supposed to, and I really don't like giving you guys work days when I'm gone because that translates to just do whatever you want. So that's why I left these specific instructions for the sub and for you, which are viewable in your math lab Schoology. So, just mention a lot of you have work to finish and or resubmit. The main thing being that MathLib, I saw that I have a few more submissions, so we'll get those graded and updated within some time. But that's rated as first priority because that's probably what's bringing your grade down. If your math lab grade is not an A right now, that's probably what it is. So that's why it's still number one. It's only 10 problems, so I'm really not sure why it's taking forever for some people to redo it and resubmit it, but that's main priority. Second priority is the practice for that day. So like yesterday, the lesson was lesson 11, and granted, it wasn't given to you in like a traditional format from me. It was given to you in the form of a Kahoot if you had me as an algebra teacher. But it's, again, nothing new. We do word problems with exponential functions all the time. So instead of giving you a few more to do, I gave them to you in the form of a Kahoot. So that's what lesson 11 was. You had a lesson 11 practice to do. Today is lesson 12. Right, so that's the one that you would then prioritize second, because that's for today. You're all here. I'm holding you all accountable to that practice for sure. If you're an overachiever, you get all that done. You make sure all your notes are up to date. You make sure all your other assignments are at 80% or higher. And I said specifically, please leave me a list of students who are using the hour as free time so that I can verify that they had everything on this list to complete. And I do have a list. So, and I know those people had stuff to complete because I literally updated grades yesterday. I saw that they were behind by like 5 assignments and they didn't even open the one that was for today. That was listed to do second. And I knew they already resubmitted this first one. So definitely they should have at least opened the practice that they were supposed to do. That would have been the first thing they did and they didn't. So those people, and I'll be talking to them, are basically on probation. Should you not do the things that you are required to do, aside from just getting exited, because you're not using it wisely, I'm not gonna let you use your phone. I will make you that specific person that's behind and still using the hour as free time, turning your phone and headphones to me every hour that you have, until that work gets done and turned in. There's absolutely no reason it's not done. We go over like half the problems every day. I'm here to help you. Some of you haven't even opened it, so that's why I'm like over it. It's not a free hour. So definitely keep that in mind. I do have my list. Some of those people on that list have everything done. Like truly, they have 100% or at least the 80% or higher is my threshold for all the mastery objectives. They have their math lib at 100%. I'm assuming they have all their notes done. So those kids, I'm not going to punish because they already got their stuff done. That's the stipulation. To have free time, you need to have all your stuff done, and a lot of you aren't. So those of you that aren't, your phone's being turned in. So questions on that? Okay. On a lighter note, we did do another lesson today. There is some new information, but by now you guys already know how to set up an exponential function, how you know that it's an exponential function. So when you read a word problem, what indicates to you that it's an exponential function? Versus like a linear function. Okay, so if they give you the equation, the way that it's set up, maybe, how do we set up our exponential function equation? With an exponent in it, Can you tell me like what the general formula would be? Someone? So this is all, what I'm asking you to do is just recall what you've already learned. So let me even backtrack again. When you read a word problem, what indicates to you that it's an exponential function? What like phrases do they use? What type of math do they make you do? Multiply by. For each amount of time, you're having to multiply to get to the next answer. Different from linear where you have to add to get to the next answer. So everyone close your screens because it's like half of this. It's annoying, honestly. You guys want to go and do your own thing, but then like this takes forever because you're not listening. So again, when you read a word problem, if it says phrases like it's doubling, it's tripling, it's losing half of its value each time, it's losing a third of its value, it's decaying by a factor of 4/3. That's not decaying, but 1/3. All right. That would tell you that it follows an exponential function format. What's the formula for that? For exponential functions? Like exponential functions all follow this format. Close. If you're doing the 1 plus, it's not a B. R. Right, and usually I'll put plus or minus so that you remember that if it's decay, that you remember to subtract the R. But even more generally, it's A times B to the X or to the T. That's what I'm asking you. So when you read problems that say it's doubling, it's tripling, it's multiplying by a factor of 2/3 each time, if you're having to multiply each time, all of that. Problems that say like this person makes $25 an hour, the pool is draining by 8 gallons an hour, something like that would be linear. And then it's the same amount it's decreasing by each time, like adding, subtracting lines. But this is our exponential functions. Today, we really focused on what happens when the A changes. So like A stands for what in exponential functions? Starting amount. Where would that be on the graph?
Your Y.
Your y-intercept. So the greater your starting amount is, the higher you would expect it to go on a graph. The lower your starting amount is, the lower you would expect it to start on the y-axis. So nothing crazy there. We also talked about what it looks like when A is negative. So that just reflects it over the x-axis. If you ever forget that, just play around with an equation in your graphing calculator and you'll see that. So A is not super remarkable, but the B for sure is. So like, what does the B tell us about our exponential functions?
Common factor.
It's our common factor. It's what we're multiplying by each time. So in that case, we learned something today, and I know not all of you had algebra yet, but how do I know that it's growth without graphing it? How do I know just from looking at the equation that it's going to be growth? The common factor would be what if it's growth?
Greater than 1.
Greater than 1. And that makes sense because remember in those math lib when it was growing by a certain percentage and you had to do 1 plus that as a decimal, it ended up being bigger than 1. When you double, triple, that's bigger than 1. You expect it to grow. So yeah, if your B value ends up being greater than 1, it's growth. So then if it's decay, what does that mean about your B value? Good. So then when, again, you did the math lib and it was now decreasing by a certain percent, you did 1 minus whatever that percent was as a decimal. So if it was decreasing by 25%, that B ended up being 0.75, it ended up being smaller than 1. You know it's decaying without even graphing it. Okay, so that's really what we did in a nutshell today. Refer back to this, those of you that haven't had algebra yet, to, successfully complete that. And if that's hard for you to constantly work ahead, we can work it out to where you're working on the previous day's lesson. And I hold you accountable to that. Most of you are here all the time, so it's not really a huge issue. But usually when you're absent, I'll excuse you from like the mastery part of that, because you already have to make it up in algebra. So I'm not excusing you from the algebra part, I just excuse you from the math part. To not overwhelm you. But some of you will let yourself get so far behind that you have a bunch of missings in math lab too now. So do the items in order of priority. So like resubmit your math loop if you still need to, do the lesson 12 and then all the other missing stuff from algebra. Question? Okay, I'll check in later, but of course you can ask as you go. I'll leave this up for an example. 11. So function h describes the height of the ball in inches after n bounces and is defined by this equation. It wants to know what is h of 3 and what does it represent in this situation. So h of 3, the way that that's represented, even like how the equation is represented, is in function notation. So you have to read the equation, compare it to what it's asking you to figure out. What is that 3 replacing? N, right? It's in the parentheses, the N is no longer there. So what you'll have to do is replace N with a 3 everywhere that it occurs. And that on the left side is just notation. It's just showing that we plugged in 3 into function h. So it's not h times 3, you just leave it alone. On the right side, I put that in my calculator. And because we're now like at the point where the only real way to get the answers is from the screen, like you all need to make sure that you're not being stubborn and still trying to do it in your head. But it was 120 times 4/5 to the third. Okay, and if you are getting something other than 61.44 and you use the calculator, then make sure you tell me. That's an easy fix. To show you how to use the calculator the right way is a really easy fix. So 61.44, any answers that say something other than that, we can already eliminate. So 2 answers say that. We need to correctly say what it represents. So it's not asking you what the 3 represents, maybe in a little bit of a way, because when we're asking what h of 3 is, the answer we really want is what the output is, which is this. It's asking you what this 61.44 represents. So what does it represent? Does it represent the height of the ball? Or does it represent the number of bounces? The height of the ball. Specifically after 3 bounces, that's what the N was representing. Like it said in the problem, N bounces. H just, well, really it would be H of N describes the height of the ball. So that's the other part, interpreting it the right way. So good on that one. Questions on others? Yes. Number 2 on lesson 12. This and sometimes graph, because I know question 2 was about which one goes with which graph, right, Lamia? Okay, so let's look at the graph and it's the same equations that are down here, it's just for number two. That it asks you to, what do you call it? Match the line to the current graph. So graphing questions are easy to confirm if you know how to use your graphing calculator. So I can show you that in a second. But today in the lesson, we learned how to compare them when it's different values for A and B. So like in this one, what's different between these? Is it the A or the B that's different? The B is different in each one. The A is the same in each one. Also, I don't like that they use like in the multiplication sign that looks like an X. I hate that, don't do that. But it's times 3 to the X and all that stuff. So here's how you can do it without graphing, and then you can just use the graph to confirm. If all that's different is the B, we know that as B increases, well, first, since it's greater than 1, would that be growth or decay? Okay, so we know that this is definitely growth, they're all growth. But as B increases, does it grow faster or slower? So like, what grows faster, tripling or quadrupling? So like, as B increases, it grows faster, the function. So like, the one that should grow the fastest is this one, because it has the biggest B value. So which line looks like it's growing the fastest? Jordan, go ahead. But I'm asking all of you, which line looks like it grows the fastest? Good. So A is h of x. Because it's the steepest, steeper lines grow faster. What's the next highest B value? 3 or 3.5? So this one should go with which graph? Good. So this one's my second fastest growing one. So that one should be g of x in the middle. We'll go with A, B, and then process of elimination. This one must be f of x. That goes with graph C because it grows the slowest out of those three. That makes sense? Okay. Do I need to go to number 2 or does that? So it should be the same graph from 1 to 2. All right, what other questions do we have?
Last one on this is good.
The last one on lesson 12. So it says, it's number 4, right? I was pretty sure there was only 4 questions. Okay. So use the graph and follow function, and the following functions find the most likely function for graph B. So here's our options. So it also tells us A is this, C is this. We're trying to find the most likely function for graph B based on its position. So B is in the middle. By the way, looking at these equations, the A's are the same and the B's are different. Which one? Because, well, first let me ask you, is this growth or decay? Decay. You could tell because of the graph one. And you can tell because of what from the equation? Good. What it's multiplying by, what's attached to the exponent is smaller than 1. These are both decay. So, in that case, you kind of evaluate it a little bit differently than growth. You have to remember that what you're multiplying by is what it's keeping. You multiply by what is remaining of it, not what it's losing. So it's not like function A is losing 4/5 each time, it's keeping that. So maybe convert it to a decimal, if that makes it easier to compare. But, we can see that A has the slowest decay rate because it's only losing 1/5 at a time. It's keeping 4/5. We should expect it to be higher. C is decaying the fastest. It's only keeping 1/5 of it. So which of these answer options also is between 4/5 and 1/5 and starts at the same place as the other graphs? Okay, we have a vote for B. Anyone think otherwise? Okay, so they all clearly start at the same y-intercept, so that's why you wouldn't pick the ones that say 120. Really between these two. And the C option on my screen, 6/5, that's actually over 1. That graph would actually be growing, not decaying. So it would have to be the one that is highlighted, 2/5 to the x power to the 6. I mentioned I would show you like how to make it look better on Desmos if you're using that to confirm your answers. So say that it was this problem that I was trying to match what it would probably be. And I was trying to, I don't know, compare it to my A and my C. So I'll type that in. And you could put the function notation. You don't necessarily have to because it'll be color coded. And then I'll put the right answer, but ideally you'd probably put all the answers and see which one best looks like B on that picture. But if you just look at it right here, it might not show you a whole lot, or it might not look as nice as like this looks. So it might be hard to distinguish when it looks like this when you put it in the calculator. What I would say is adjust the window to match the axis of this graph. So how you adjust the window, you would hit this wrench, see what it was for the x-axis on the graph that was given to you. I think it went from like 0 to 4. We can round to 5 on the x. And then on the y, it went from like 0 to 160, maybe even above that. So we can go 180. Change those values so that it now looks like the window of the graph you were given. Okay? That way it's easier to compare. So that purple line is my right answer. If I put in any of the other ones, like what was it, 120? And now does not look like the same graph. I love when there's graphing questions on the test because that should be like easy for everyone, hopefully. Because you have a graphing part of your test. All right, other questions? From any Unit 5 stuff from the past few days at all? Yeah, question? Number 9 on lesson 11. Okay, so the table shows the number of people N who went to see a musical on the D-th day of April. So like, they don't know what day exactly, they're using a variable. What is the average rate of change for the number of people from day 1 to day 7? So average rate of change, you should automatically be thinking of what? Wait, am I on the right one? That's all it is, one thing, okay. Sorry to interrupt. What should I automatically think of? Okay, good. And with average rate of change moving forward from our linear functions, you really have to pay attention. Where do they want me to look? You can't just pick any two parts. It has to be where they want me to look. So from day 1 to day 7, that would be this coordinate. And that coordinate that we're plugging into our formula. Don't skip the labeling step. I'll make this one x1, y1. I'll make this one x2, y2. Now you could have labeled it differently, like this x2, y2, this x1, y1. You should still get the same answer if you do it right. So the way that I labeled it, it would be 1534 minus 1720. Y2 minus y1 over 1 minus 7, the way that I did it. So then I get 15, 17. I get negative 186 over 1 minus 7, which is negative 6. Correct me if I'm wrong. Okay, I sometimes doubt myself in the morning, so. A negative divided by a negative is a positive, and when I put it in my calculator, it gives me 31 exactly. And I know we talked about like if it was a decimal, like only look at the number part of it. Since this is average rate of change, if it was a decimal for your average rate of change, you would put the decimal. Okay, because obviously, like we know you can't have a fraction of a person, but average rate of change is allowed to be a decimal. So I would put 31 and it should mark that right. I think that's all we have time for. Those of you that turn in your phone or headphones, you can come get them. I do